Hi guys. All right, today we're going to talk about multiplying. And on Monday we started talking about the same, but we had the whole number first and the fraction second. And so today we're going to switch it around and talk about what it means when we have the fraction first and the whole number second. And so these are the notes that we're going to take. And we're going to go through them and talk about them a little bit more and kind of break them down and discuss about what they mean. So over here we've got, let me rewrite this, we've got 2/3 times 4. And the other way that we had it on Monday, it was written 4 times 2/3. And so you get the same exact answer. You'll still get 8/3, which equals 2 2/3. So whether you put the fraction first or the whole number, you'll still get that answer. But what we're talking about when we had the whole number first, we were doing 4 groups of 2/3. So we were taking 2/3, repeating it 4 times, and thinking it as a repeated addition, and doing it that way. Here we're putting the fraction first and the whole number second here. So let me get rid of this. And so here I want you to think of this multiplication symbol as of. So this is 2/3 of 4, which means that we need 2/3 of 4 wholes. So if we take 4 wholes, so here's 4 wholes, and we're going to break them into 3 parts. And we're going to show 2/3. So there's 2/3, 2/3, 2/3, and 2/3. So 2 out of the 3 parts are shaded. We want to know what 2/3 of 4 is. So we can do this a couple ways. So if we have the models, we can take some of the pieces and just rearrange them. So I could take these 2 pieces and put them here. So one part could go there, one part could go there. And then there I see, I can't move these right here. I can't move those anywhere. So I'm going to leave those. So here's 1 whole plus 1 whole plus 2/3. So there's my 2 wholes and 2/3. So I can use the models that way, or I can multiply it out to where I would have 2/3 times 4. And when we write the whole number, I can write it as a fraction by putting it over 1 and then multiplying across. So 2 times 4 is 8. 3 times 1 is 3. And then I can take that improper fraction and put it as a mixed number. So I'm going to pull out those wholes. So I'm going to look at my denominator, which is 3. And so to make 1 whole, that would be 3/3. And same thing here. I had to have 3 parts out of 3 shaded in to make the 1 whole. And so I've got 8 parts, so I've used 6 of them so far. So there's 2 left over out of 3. Whoop. And so that's 1 whole, 2 wholes, and 2/3. So either way, you can multiply it out, or you can kind of, if you're given the picture of it, the model, you can rearrange those parts and slide them over to fill them in and see what they are combined. So we're counting all of the pieces, and then if we're multiplying it out, once we get all those pieces together, we need to change it into a mixed number. So that's one way. And then let me get rid of this here. All right, so on the bottom here, we've got 3/4 times 12. And so again, this means 3/4 of 12. So let's say that we have 12 of something. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So if I want 3/4 of that 12, then I need to think about how I can take these 12 wholes, these little X's each represent a whole. I need to think about how I can show or I can find what 3/4 of them would be. So if we think about the fraction 3/4, what this means is we've got this denominator 4, and the 4 represents how many parts the whole has been represented. So if we're thinking, this is parts of a whole, so if we're thinking about this as one big whole, how would we break this into 4 parts? And what you can do is think about like dividing this off. So like these right here would be 1 part. This would be 2 parts, 3 parts, and 4 parts. So I've taken my 12 wholes and I've put them into 4 equal parts. And then now I want to know if I have 3 of them. So that would be this one, that's 1, 2, 3 of those out of the 4. How many would that be? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So this should equal 9. So that's what it looks like with the picture. Let me see when I multiply that, show you what that looks like. All right, so here we have 3/4 times, this is going to be 12 over 1. We're going to rewrite it as a fraction. 3 times 12 is 36, and 4 times 1 is 4. And I know that if I were to take this improper fraction and rewrite it as a mixed number, I would be able to pull out 1 group, 2 groups. I'm taking 36 and I'm pulling out groups of 4. Because every time I do that, I make a whole. So there's 4, 8, 12, 16, 20, 24, 28. All right, let's see. 4 was 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times 4 is 36. So that all of those 4s, if all the numerators, if I would have added them all up, they would have equaled 36. And the denominator all stays the same, so all the 4s. So this is, when I count the wholes, I've got 1 whole, 2, 3, 4, 5, 6, 7, 8, 9. So this equals 9 wholes, which matches. Another way I could do it is turning this into a division problem. So 4, I know, goes into 36 9 times with no leftovers, so just 9. So if you've got your multiplication facts down, you can just, like, you should be able to easily find that. If you still need to do this part where you're breaking it down and decomposing it, that's fine. It's just going to take you a little bit longer, but you can do it that way as well. So we can represent it with those models like that, or we can do it with the algorithm. But thinking about where those are, so again, with the fraction is at the beginning, you're thinking it's 3/4 of 12. and just thinking about, okay, what that means. Like if I have 12 of something, what would 3/4 of that be? Erase this. All right, let's do a couple more. So let's say we want 2/3 times 36. So here I've got 36, and that's kind of, it's a little not unreasonable, but it's kind of a larger number to be drawing out. So I'm going to go ahead and I'm just going to multiply this straight across. So I'm going to make my whole number into a fraction, and I'm going to multiply across. So 2 times 36, that's 36 2 times, so that would be 72 over 3. And that is a lot of group of threes. Like if I was going to do 3 over 3, 3 over 3, that's a lot of them. So I'm going to, on this one, I'm going to turn this into a division problem because that other way would take me a really long time. So I'm going to turn this into a division problem. So the 3, I'm seeing how many times 3 can go into 72. So 3 can go into 7 2 times. 3 times 2 is 6. Subtract, you've got 1 left over. Bring down your 2, that can go in there 4 times. 3 times 4 is 12, and there's no left over. So 72 over 3 is the same as 24. Since there's no remainder, that means there's no fraction. So just 24. So this. Get rid of that one too. All right, let's try one more. So let's do 4/5 of 20. This is the same thing as 4/5 times 20. So here, if I had 20 of something, let's go ahead and draw this one out. If I had 20 of something, I want to find 4/5 of that 20. So I'm going to go ahead and peek at my denominator, and when I go to draw out my 20, I'm going to put them in groups of 5 just to make it easier to separate. So I'm going to do 20. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And then I'm going to find, so there's my 20. I'm going to find 4/5 of this. And so, I've got, I need to put them into 5 groups. So I'm going to let me grab another color. So I see here that I can do it like this. There's one group, and I want my groups all to be the same. 2, 3, 4, 5. So there's 5 groups. And then if I have 4 of them, that would be, here's 1, 2, 3, 4. So all of this would be 4/5 of the 20. And then when I go to get my answer, I just need to count. So I'm counting the x's. So there's 4 here. 4 plus 4 is 8. Plus another 8 would be 16. So this should equal 16. So let's go ahead and multiply it out and check our answer. So 4/5 times 20 over 1. 4 times 20, 4 times 2 is 8. Add your 0. 5 times 1 is 5. And then if I'm counting by 5, so 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that 16 matches. So there's, if I were to divide that out, it goes in perfectly 16 times with no remainder. So since there's no remainder, it's just 16 holes. It goes in there perfectly. No leftovers. All right, so that is how we multiply, starting with a fraction and multiplying that fraction with a whole number. So hope that helps.